Section 1.7, thank you, ma'am. I pled with you, please print the notes so that you can keep up today. We're going to try to do as many examples as we can. But the very first problems in 1.7 are just practicing translating English sentences into algebraic expressions, algebraic equations. So the first one, from geometry, the circumference of a circle is the product of the number and twice the radius. Anytime you have a sentence with the word is in it, that's probably where your equals goes. 99 times out of 100, my equals is going to be right there. And the words before the equals are going to be the left-hand side of my equation. The words after the is going to be the right-hand side of my equation. So to the left of the equals, the circumference of a circle, what would you like to use to stand for the circumference of a circle? Kind of boring, but it works. All right, so C equals, and then the right-hand side, what does the word product mean? Multiply the number and twice its radius. Let me read that one more time. The circumference of a circle is the product of the number and twice the radius. You know what? I think a little pi was left out of that. I think there's a typo. It's the product of pi and twice the radius. So that's a typo on my part. What does twice the radius mean? Ooh, that's the most common wrong answer. I paid you to say that. It's not r squared, or the words would have been r squared. Twice means double or 2 times, not squared. So the number pi and twice the radius is pi times 2r. And that's the formula for circumference of a circle. Just C equals pi times 2r, or usually it's written 2 pi r. Same thing. That one was easy because you probably had that formula memorized anyway. Number 10, the perimeter of a square is, well, there's where my equals goes, 4 times the length of a side. To the left of the equals, what do you want to use to stand for perimeter of a square? P. Again, boring, but it works. What's 4 times the length of a side? What variable are you going to use for the length of a side? You can use L for length or S for side. It doesn't matter. You can use X, which really doesn't stand for either one of those words, but as long as you understand what your variable stands for, you can use it. If you use S for side, then P equals 4S is that formula. You could, L or S, whatever you wanted, or X. The reason I chose S is in most math books, they'll label a square with side S, and then just 4 of those sides gives you the perimeter. Number 12, pressure is, there's where my equals goes, and to the left of that, I'll use P for pressure. What about force per unit area? I don't know if that's telling me to add something, multiply, divide, take one.
Every unit of area has a set force.
But is multiplying the thing I need to do there? What does the word per indicate? All right. And when you go, let's say you go 60 miles per 2 hours. Instead of 60 miles per hour, if you're going 60 miles per 2 hours, how fast are you really going? 30 miles an hour. You divide. Per is divide. So that means divide your force by your area.
Oh, that makes sense. You're right.
Exactly. That's why. Yeah. All right. So force per unit area could be F divided by A. Number 14, kinetic energy is 1/2 the product of the mass and the square of the velocity. Getting just a little bit more complicated, but here's where my equals goes, right under that is. And what variable would you like to use for kinetic energy? K is fine, E is fine, anything you want is fine as long as you know what your variable stands for. We'll use K for kinetic energy. 1/2 the product of the mass and the square of the velocity. How will we write the square of the velocity? V squared. How do we write 1/2 the product of the mass and that? All right, 1/2 of M, and product means multiply. I could put a dot in there for multiply, but I don't have to, because without a symbol, if you write M beside V square, it means multiply. So the simplest way to write that would just be K equals 1/2 mv squared. And if you take any physics course, you'll see that formula in the book. Number 16, the total revenue derived from selling X dishwashers is $250 per dishwasher times the number of dishwashers sold. All I know is this is where my equals goes. Y'all have to help me with the rest. What's to the left of the equals? Is that what the words to the left say? The revenue derived from selling X dishwashers. It's just revenue. It's just revenue on the left-hand side. Well, the 250 is on the right-hand side of the equals. All of this on the left just means the revenue is. So R equals $250 per dishwasher times the number of dishwashers. That's kind of sneaky because we just discussed force per unit area is force divided by area. This $250 per dishwasher, if you're putting the units in your equation, which you don't want to do and I won't do over here, but right here, if I write $250 divided by the number of dishwashers, that's not how you calculate revenue. It's $250 per dishwasher times the number of dishwashers sold. If you worked at Lowe's and I said, hey, you've sold 5 dishwashers today for $250 each, instead of using the word per, how would you calculate how much revenue? 25 times 5, or 250 times 5. Yeah. So when I say per means divide, 99% of the time it does. 99% of the time is means equals. But just think if it makes sense in terms of that problem, your revenue is how many you sell times how much you sell each one for. Maybe the word each would have been less confusing there. Miss Christina, why are you still frowning about that? You believed me when I said per means divide, and you're going to do it no matter what. Don't get that attached to some rule, because there are times when of means multiply, and then there are times when of doesn't mean multiply. But think about how you find it does 90% of the time, but that other 10%, I could just be asking for a piece of bread, and I don't want you to multiply piece times bread. Okay, we should have started with yoga then. We should have started with a deep breath and some yoga position. Make sure everybody, if you've hated word problems your whole life, put that aside right now. Give me a chance, all right? The key to solving word problems is using words. Some folks think that if they were smart, they'd be able to just read this problem. Betsy, a recent retiree, requires $7,000 per year in income to supplement her Social Security. She has $50,000 to invest and can invest in B-rated bonds paying 15% per year or in certificates of deposits paying $7 a year. How much should be invested in each to realize $7,000 in interest per year? And then just write down the equation. Well, maybe after you've done 40 of these, you can read it and just write down the equation. The rest of us need to come up with words for the numbers that we're given, words for the number that we're looking for, and then we need to think in English because that's how we've been thinking since about 1 year old. All right? You didn't start thinking x plus 2 equals 7 until way after that. So let's try to use some words here. And those folks who still hate word problems after practice, a lot of them aren't buying what I'm selling. What I'm selling is the idea of writing down words on your paper. And maybe you feel like you shouldn't have to do that in a math class. I'm telling you, based on a quarter-century experience, it will help you with word problems if you try to think in words instead of X's and numbers. All right, so let's see if we can do it. Read that again. She needs $7,000 in income to supplement her Social Security. This is another thing I do when I'm solving word problems. Just take each sentence and make sure you understand what that sentence is saying. She's retired. She's getting some set amount of Social Security every month, but it's not quite enough. She needs an extra $7,000 a year on top of what she's receiving in Social Security. So she's going to take some of the money that she has squirreled away in a savings account and put it where it will earn a little bit more interest so that she gets that extra $7,000 a year she needs. And that $50,000, she has two options. She can either invest in bonds that pay 15% per year or in certificates of deposits that pay 7% per year. Well, if you had an option that paid 15%, why wouldn't you put all $50,000 there? Very good. Because of risk. The reason that interest rates are higher on some investments than others is due primarily to the risk factor of those investments. The higher risk you're willing to take, the more interest you stand to gain, but the more you also stand to lose. So in the investment market, you have to decide what level of risk that you're comfortable with. But that's why Betty's not just taking all $50,000 and putting it in bonds. Those bonds are higher risk, and she doesn't want to take the chance of losing everything. The other thing I'm going to try to sell you in this section, not only using words, but try to make a table to organize the information that you're given. If you can organize that information with words, you can solve the problem. You can set up the equation. All right. What are the pieces of this puzzle? What two things are being mixed or invested or something? I'm looking for some words to go right here. What's this problem? All right, but actually, let me just tell you this one, and then you can tell me the same thing on the others. I'm having trouble wording this question in a way that is invoking you to say what it is that I want you to say. The two things that are being mixed are bonds and CDs and amounts of money in each. So down my first column here, I'm going to have a row for bonds, a row for CDs. And if we were talking about different kinds of nuts, I'd put mixture there. Since we're talking about different kinds of investments, I'll put total there. Doesn't matter. It is a mixture. But when you're talking about money, you usually say total instead of mixture. Now, what is the most important formula for interest that you learn in, I don't know, 7th, 8th, 9th grade? There's a most famous simple interest formula. Miss Josie, are you thinking of it? Tell me. I'm not going to smack you if you're wrong. Yes, your interest is your principal times your rate times your time. That definitely has to come into play in this problem. The important things about the bonds and the CDs is how much money I invest in each, and the word for that in the investment industry is principal. And then rate times time. Rate is another important factor here. At what percent interest each investment yields. And the only reason we don't need time, a column for time, is this is for only 1 year. If we had anything other than 1 year, we'd need a column for time, but this is $7,000 per 1 year that she needs. So I don't have to have a time column. I'm just going to say principal times rate equals interest. I feel, and I have no scientific evidence to back this up, but I have a lot of experience. If you can have your table labeled in a way that you understand what all those words mean and how they fit together, then you're 80% of the way in solving word problems. You've captured the important parts of that problem. So now let's start figuring out where these numbers go. What is that? Where does that 7,000 go? And you not only have to give me a row, you have to give me a column. Tell me in what row and in what column that $7,000 goes. It's rate. No, I'm sorry. That's not what you said, and that's not what I meant. It's a total, and it's total interest. It's not total principal. It's not how much she's going to invest. It's how much she hopes to earn. So that 7,000 goes right here. Where does the 50,000 go? And you've got to give me a row and a column. It's the total principal, how much she has to invest. So the 50,000 goes right here. What about the 15%, which I'll write as 0.15? In what row and column does that go? It's the rate of the bonds, 0.15. Make sure you write those percents as decimals. And where does the 7% go? That's the rate of the CDs. Are there any numbers that I don't have on my chart yet? Nope. That's all I was given. Now I have to figure out what I'm looking for. How much should be invested in each? What's another word for how much is invested? That's the, starts with a P. Principal. That's the principal. So we're looking for the principal that was invested in each. We could either use two variables and set up two equations, just like we did on that first test. We had a problem similar to this. We could say x plus y equals 50,000 and then multiply across and say this interest plus this interest equals total interest. That's fine. I can do it with one variable. I'd rather do it with one variable. If we say x is the principal in bonds, and I know that the total principal is 50,000, what if I end up finding out that I've invested $20,000 in bonds? How much will that leave in CDs? 30,000? How'd you get that? You subtract the amount in bonds from the total amount, and that leaves you how much is in CDs. Now, is that x minus 50,000? It's not part minus total. You have to have total minus part. Order matters when you're subtracting. So 50,000 is the total, and X is one of the parts. So 50,000 minus X is the other part. Now think about it. If, let me come back to that idea in just a minute. All right, now just multiply straight across to get your interest for your bonds, 0.15x. The interest from your CDs will be 0.07 times 50,000 minus X. And the sentence that absolutely makes sense here is the interest from your bonds plus the interest from your CDs has to equal your total interest. And I'm thinking those words. I'm not thinking 0.15x plus 0.07 blah, blah, blah. I'm thinking the words to see if my sentence makes sense. I'm going to write that down. The bonds interest plus the CDs interest is the total interest. And after you practice a bit, you don't have to write your sentence down, but when you're first struggling with word problems, that sentence helps a lot. It tells me exactly where my equals goes. I can see where my plus is. And in the place of bonds interest, I'll put what? 0.15x. What will I put in place of CDs interest? 50,000 minus X. That's okay. Just making sure you weren't multiplying there. And total interest, that's 7,000. Now, if I just walked up to you in the mall one day and said 0.15x plus 0.07 times 50,000 minus X equals 7,000, you turn and run because only a crazy person would say that to you. But if I come up to you and go, you know, I've got money in bonds and money in CDs, and my interest from each is the total amount of interest, you just say, duh. Obviously, that just makes sense. Well, word problems make sense when you use words to solve them. All right. Finish that equation. I always laugh to myself when somebody says, I hate word problems, but I can do them if you just set it up for me. I'm like, okay, then you can't do word problems. You can just solve equations. Yay! That's the first step, but you've got to learn to set it up to use it in real life. 0.07 times 50,000, 3,500. By the way, I need to employ one of you to be my calculator. Okay, thank you very much. Then combine like terms, 0.15x minus 0.07x, that's just like 15 cents minus 7 cents is 8 cents. Subtract 3,500 from both sides. 7,000 minus 3,500 is 3,500. And then divide both sides by 0.08. 3,500 divided by 0.08 is what? Anybody second that? All opposed? All right, motion carries. It's 43,750. Now, Miss Betsy is a precious, precious sweet lady. She needs the aid of a cane to hobble in the bank and ask you this question. Are you going to sit across the desk from Miss Betsy, do a little bit of figuring, and say, Miss Betsy, X equals 43,750? She's going to whack you with that cane because that makes no sense to Betsy. Betsy said, how much should I invest in each account? So how are you going to answer Betsy? All right. Yeah, that's not what you're going to say to Betsy. Put 43,750 in place of X. Just play like you just got hit with a cane. Yes. You can say that because Betsy's sharp. She uses a cane, but she can still subtract. So you tell Betsy to put $43,750 in bonds, and if you tell her the remainder in CDs, she'll be able to figure it out. But if you don't even want her to have to do that, how will you figure out how much she should put in CDs? 50,000 minus that, which is $6,250 in CDs. Make sure you answer the question in the way that it would make sense to the person asking the question. X equals 43,750 is never the answer to a word problem. All right. Right now you're thinking, hopefully, that makes sense, right? If you're being objective, if you're not coming in here going, I hate word problems and I'm going to leave them blank on the test no matter what, then maybe it doesn't make sense. But if you're open-minded and trying to think in words, that made sense. Those words made sense. So let's try to do another very similar one. Number 20. By the way, Miss Betsy might leave you something in the wheel if you haven't messed up on that. And she has her 7,000. If you get her 7,200, maybe she'll give you the 200 every year, just for being nice. Wendy, a loan officer at the bank, has $1 million to lend and is required to obtain an average return of 18% per year. If she can that's lend, and the L got chopped off. If she can lend at the rate of 19% or at 16%, how much should she lend at 16% and still meet her requirement? I don't read that and start writing down X's. I read that and start writing down words. And if the problem is about investment, I already know what goes across the top of my chart. I know that it's going to be principal times rate equals interest. Now, what are the two things being mixed here? We don't have names for them. You can make up your own names for them. You can call them loan A, loan B, cheap loan, expensive loan, whatever. You use words that make sense to you. I'm just going to say loan A and loan B. And for each one of those loans, either I know or I can calculate the amount of principal at that rate, the rate of each loan, and the interest each loan will yield. And there is a total here. What's the $1 million? Give me row and column. That's the column. What's the row? It's the total principal. It's not how much she's going to put or but loan in either loan. It's the total principal. Where does the 18% go? If I put it, I'm going to write it real lightly so I can mark it out. If I put 0.18 for total interest, then I'm saying Wendy wants to earn 18 cents off this $1 million. Wendy's hoping to earn 18 cents. That's not an amount of dollars. That's a percent, which is a rate. All right. So it's not the total interest, it's the total, or actually average rate. The other two rates are 16% and 19%. Doesn't matter which one you call loan A and which one you call loan B. Help me figure this out. Let's think about what a reasonable answer would be here. If out of that $1 million, she has to average 18% interest, is she probably going to have to put more at 16% or more at 19%? If she wants to average 18%, she's going to have to put most of it at the higher rate. So that's just something when we come up with answers, we can use that to say, does that sound right? All right. Are there any numbers I don't have placed yet? All right. We have all the numbers from the problem where they go. So now it's time to start thinking about variables. And you're right. The question is, how much can she lend at 16%? So I'd rather let that principal be X than the other, because I'm going to end up solving for X. Let's play like we solve and find out that she's going to invest 20,000 or 200,000 at 16%. How will you get the amount at 19%? Million minus 200,000. It's always total minus part that gives you the other part. So $1 million minus X. Is that the same thing as X minus $1 million? No, it's not. It matters. Now that we have the first two columns filled in, we can fill out that third column. The interest from loan A will be 0.19 times $1 million minus X. The interest from loan B will be 0.16 times X. And the total interest will be 0.18 times $1 million. And you can go ahead and do that if you want to. Multiplying by $1 million moves the decimal 6 places to the right. So I would have to add 4 zeros. 18% of $1 million is 180,000. So in words, with no numbers and no variables, tell me what my equation needs to say. What's my sentence? That's very close. But when you say loan A plus loan B, you're giving me the row. And I don't know if you mean the loan A interest plus loan B interest equals total interest. You need to give me a row and a column. That was the hard part. Hard part's behind us now. Loan A interest is 0.19 times $1 million minus X. Loan B interest is 0.16x. Total interest is 180,000. Clear out parentheses. Combine like terms and subtract 190,000 from both sides. And divide both sides by negative 0.03. Comes out to be 333,333 and on and on. All right, but it is 333,000. Okay. Where do you think the bank will stop rounding? What's the most precise the bank can be? To the nearest whole penny? Yeah, to the nearest whole penny, it would be 3.3. And so what do you go back and say to Wendy? Except for that I made up the A and B. Wendy didn't give me those. So instead of calling it loan B, I'm going to say the 16% loan. Yeah, that's what you need to tell Wendy. Invest $333,333.33 at 16%. And if this had asked me for how much should she invest at each, then I'd subtract that from $1 million and find out that she needs to invest about $666,666.66 at 19%. Is that what we were expecting? More money at the 19% than the 16%? Yeah. If she has to average 18%, she's going to have to loan more at the higher rate. If the bank had loans for 19% and loans for 16%, why would anybody take out the 19% loan? Why would they have no choice? Yeah. Lending money is just like the bank investing in you. And they assess your risk factor. What's the probability that you won't pay back that loan? So they charge a higher rate for a higher risk, i.e. folks with poor credit scores, than just like if you were going to invest money, your higher yield investments would come from the higher risk opportunities. All right. So you could do any investment problem in the whole wide world right now, right? But if you don't practice a few of them soon after this class, none of those words will be in your head tomorrow night. None of them will be in your head on test day. You have to practice by writing these words down, moving them from short-term memory to long-term memory as soon as possible after class. All right, number 22 and 24. We'll call both of those mixture problems. And really, investment problems are mixture problems. You're mixing two loans or mixing two accounts. But in number 22, we're mixing two coffees. A coffee manufacturer wants to market a new blend of coffee that sells for $3.90 a pound by mixing two coffees that sell for $2.75 a pound and $5 a pound, respectively. I already know the two things that I'm going to be mixing. I can call them whatever I want: coffee A, coffee B, cheap coffee, expensive coffee, Folgers, Starbucks, whatever you want to call them. It does not make sense to put interest or principal times rate equals interest across the top of a coffee problem. We need new words here. What is important about each of those coffees? The number of pounds is very important. What else? The price per pound is very important. Doesn't matter in what column you put those, but I'm going to say number of pounds in my first column and price per pound in my second column. Give me words for what I get if I multiply number of pounds times price per pound. If I was buying 2 pounds of candy, that's $5 a pound, and I multiplied and got 10, what is that 10? That's the total. You could say total price, total cost feels better to me, but total something. First, you get your chart labeled, and then you figure out where the numbers go. What is that 3.9? That is, you gave me a row and a column. Very good. That's the price per pound of the mixture. 3.9, 3.90, same thing. The two coffees being mixed are 2.75 and $5 per pound. Sounds like that will finish off my middle column. What other numbers do I have? What amounts of each coffee should be blended to obtain the desired mixture? Well, it's helpful that they give us an amount here. Let's say we want to make 100 pounds of this $3.90 coffee. Where does the 100 pounds go? Number of pounds in the mixture. The question is, how much of each should I use? So I could either have two variables, or I could say, if we let X be the number of pounds of the cheap coffee, then how many pounds will that leave of the expensive coffee? 100 minus X. Is that the same thing as X minus 100? Absolutely not. Multiply to get that third column. And on the bottom row, 100 times 3.9 is $390. Using the words on that chart, make me a sentence that makes sense. Nope, that's not, well, those are words, but I don't want numbers and letters yet. Didn't mean to cut you off. I'm sorry, that sounded rude. Wow. You still threw a number in there at the very end. But yeah, that's, you don't just need to say coffee A plus coffee B, because if you do, I don't know if you're talking about the price per pound or the number of pounds. You got to give me a row and a column. So the total cost, and I'm just going to say cost of coffee A plus the cost of coffee B is the total cost. Yeah, I should say that, of the mixture. Does that sentence make sense? whether you've hated word problems your whole life or not. Does that sentence make sense? Yeah, absolutely. What do I put in place of the cost of coffee A? 2.75x. See, if you're not thinking in terms of words, you might just put down 2.75. But that's not the total cost of the coffee. It's 2.75 per pound times the number of pounds. Same thing for coffee B. Got to be not only the price per pound, but multiplied times the number of pounds. And then we've already done the multiplication for the mixture. The total cost of the mixture is going to be $390. The most common mistake from people who aren't trying to think of words here, they're just trying to get some numbers and X's down on paper, they'll have 3.9 there. To which I say, really? You're going to sell 100 pounds of coffee for $3.90? Either it's really bad coffee or sign me up. All right, let's solve that. What did you get for X? All right, 48, call it 48.9, I guess. If we're not told specifically what to round to, then just use your best judgment. I think in the back of the book, they will have left that as a fraction. The 0.88888 is 8/9. I think they have 48 and 8/9, but you don't have to know that. I'll tell you what to round to on the test. Don't go back to this Starbucks manager and say X equals 48.9. Say what? That X is a pounds of coffee. It's not $48.90. We let X, if you've forgotten what you let X be, just look back at your chart. That's under pounds of the cheap coffee. All right, and to be clear to the person who asked the question, I'm going to say $2.75 per pound coffee. I don't want to insult them by calling it cheap coffee. And then how much of the more expensive coffee? Yep. They're supposed to add up to 100. Then you need to use 51.1 pounds of the $5 a pound coffee. All right. Another mixture problem. Mixing caramels and creams in a candy store. A candy store sells boxes of candy containing caramels and creams. Guess what goes down the right-hand column of my table? All right. If you don't at least have that much on the test, I'm going to come hunt you down. I'll figure out what to do when I get you, but it's not going to be pretty. You can at least put, I have caramels and creams, and I'm going to mix them together. Candy store sells boxes of candies containing caramels and creams. Each box sells for $12.50 and holds 30 pieces of candy. All pieces are the same size. Not sure that's relevant, but okay. If the caramels cost $0.25 each to produce and the creams cost 45 cents each to produce, how many of each should be in the box to make a profit of $3? What's important? What words need to go across the top of my chart? Well, it's actually not price per candy we have, it's what? Cost per candy. Yeah, they tell us how much it costs to produce each one. So cost per candy. Yeah, number of pieces or number of candies. Doesn't matter what you call it. Total. Yeah, total. We're not talking about amount sold. We're not talking about price. What are we talking about? What do you get? What do you get if you multiply number of candies times cost per candy? Total cost. Yeah, if you multiply number of candies times cost per candy, you can't get total revenue or total profit from that. You're going to get total cost. So let's figure out where the numbers go. The box sells for $12.50. Where does that go on the chart? Is that what the $12.50 is? The total cost of the mixture? Maybe that doesn't go in the chart. Don't put it under total cost because it's not a cost. It's a how much, it's a price. It's how much it sells for, not how much it costs to make. You know what? I could even, if I wanted to be even better with my words, I could say total cost, this is to produce. That's how much it costs to make the caramels and the creams. So let's not worry about that $12.50 for a second. I don't think it goes on here. It's not a cost. What about the 30? You're one step ahead of me, but absolutely right. Hang on to that just one jiffy. Where's the 30 go? It's got to give me mixture, number of candies in the mixture. And the mixture is a box, so it's the number of candies in a box. The caramels cost 25 cents to produce. Where does that 0.25 go? Give me row and column. Caramels cost per candy, 0.25. Where does the 0.45 go? Creams cost per candy. What about the 3? The 3's not a cost. Yeah, the 3's not a cost either. So I've got a $12.50 I don't know what to do with. I have a 3 that I don't know what to do with. I'm aware of that. Let me do one other thing and I'll figure out what to do with that $12.50 and 3. Let's let the number of caramels be X. Then how many pieces of candy will be left to be creams? Is that the same as X minus 30? Absolutely not. And the reason I keep saying that is I keep seeing that on test. It's not the same thing. What's the total cost of producing the caramels? 0.25x. What's the total cost of producing the creams? 30 minus x. I'm not given a total cost that I'm trying to achieve. I have the selling price of the candy, and I have the profit that I hope to make. How will I get the total cost of production if I know I'm going to sell the candy for $12.50 and I want to have $3 left over? How much can I spend on making the candy? $9.50. Yes, sir.
It says each box, which each holds 30 pieces apiece, sells for in total $12.50.
Mm-hmm.
Could you possibly divide $12.50 by 30, make that an equation for the cost of candy, or would that?
That would actually be assuming that all the candies cost the same price. If you divided 12.5 by 30, you're assuming all the candies cost the same thing, and they don't. Some of them are 25 cents, some of them are 45 cents. So let me write some words down for you here. Profit equals revenue minus cost. That's the definition of profit. And if you're going on to business calculus, please know that when you get there. The profit I want to be $3. The revenue from a box is $12.50. And then the cost, wait, something's turning out funky here. Oh, nothing. If I was solving that equation for cost, I would subtract $12.50 and I'd get negative $9.50, but then I'd have to divide by -1. I'd get positive $9.50. That's how much I can spend on manufacturing the candy. And some of you, your gut just told you, hey, subtract the 3 from the $12.50. That's fine. If God's speaking to you, you listen. But otherwise, you're going to have to come up with some words that tell you what to do with that $12.50 and that 3. And the words you need are profit equals revenue minus cost. That was the hard part of that problem, realizing that $12.50 and 3 don't go on the table. I have to use them. If you solve for cost, you still have revenue minus cost. You'd still have to divide by -1. All right. So total, the cost of caramels plus the cost of creams equals total cost of the mixture. And we're not talking about how much we'll sell them for. We're talking about how much it costs us to make them. We're not going to finish that one because I believe you could. I believe that you could do that on your own, and I have some more I need to show you on the back in the next 15 minutes. So number 18 and 20, you can call those, where is it? Right there. You can call those investment problems if you're looking for a name for them. But really, investment problems are mixture problems. You're just mixing dollars instead of mixing candies. 22 and 24, you could call those mixture problems. One we're mixing coffees, one we're mixing candies. Be the same for mixing different types of nuts. Oh, fabulous. The best kind of all, 26 and 28. Are distance problems. Video? Yes. If everything's going well and it's actually recording, then yes. Okay. All right. Number 26. A motorboat heads upstream on a river that has a current of 3 miles per hour. The trip upstream takes 5 hours and the return trip takes 2.5 hours. What's the speed of the motorboat? This reminds me of one of my all-time favorite cartoons where this guy, maybe I've already told y'all this. Have I already told y'all my favorite cartoon? This guy is standing before the pearly gates and St. Peter says, before I can let you in, there's one question you have to answer. A motorboat heads upstream and the guy just goes, send me to hell. I don't do word problems. All right, let's see. What do you think probably goes for my row headings? Not two things I'm mixing, but maybe two parts of the trip. Yeah, that makes sense. Any problem that involves distance is probably going to involve two other quantities. What? The speed or rate and the time. All right, what's the most famous formula involving rate and time and distance? Rate times time equals distance. Every one of these charts, we've had two things multiplied together to give us the third column. You need to know rate times time equals distance. All right. Now, earlier when I said, before I do any more writing, I want to see if my gut knows what's going on in this problem. I'm trying to picture what's happening. There's a motorboat. It has a speedometer. The captain is holding that accelerator to some constant speed. We don't know how fast the motorboat's going, but we know that it's a constant speed. Now, I've kayaked enough, and even without kayaking, I knew that going upstream is going to do what? Slow the boat down. And going downstream is going to speed the boat up. So if I'm holding the accelerator down at 40 miles an hour, and then I'm in a current going against a 3 mile an hour current, what's my progress rate actually going to be? 40 minus 3, because going upstream, the current's slowing me down. Going downstream, I'm still holding the accelerator at 40 miles an hour, but how fast am I actually going to be going? 43 miles an hour, because the current speeding me up. The fact that the problem says, what is the speed of the motorboat, tells me what to let X be. I'm going to write it down here. Let X be the speed or the rate of the motorboat. If the current is 3 miles an hour and I'm holding the accelerator down to X miles an hour, how fast will I actually be going upstream? X minus 3. Upstream, the current is slowing you down. And then when I turn around and go downstream, I'm holding the accelerator at the exact same speed, but I'm going downstream. How fast am I actually progressing? X plus 3. Those of you who haven't been on the river very much, you just to make sure this is not going to mess you up at home, upstream is against the current. And downstream is with the current. All right, what other numbers do we have? What is that 5? Give me a row and a column, time upstream. And the 2.5, time downstream. How do I get that third column? Yep. But on all the other charts, I've had 3 rows. It doesn't make sense to say, actually that does make sense to say that. Let's play like I didn't say that. It does make sense to say time upstream or distance upstream plus distance downstream equals total distance. That sentence does make sense, but I don't know total distance, so it doesn't do me any good. What else do I know about the distance upstream and the distance downstream? They equal each other. Yeah, if I put in my kayak in Kingston and take it out in Reliance, and I'm not even sure that's possible, and then turn around and go back to where I came from, the distances are the same. So upstream distance equals downstream distance. Upstream distance is 5 times x minus 3. Downstream distance is 2.5 times x plus 3. Clear out parentheses. Your x is on one side and your constant's on the other. What is x? 25? Nope, what? 9? 9 times 2.5? Yep, that sounds better. Is that dollars? Is that pounds of caramels? What is that? Miles per hour of the boat. I can kayak that fast. This boat doesn't even need an accelerator. It just needs a paddle. 9 miles per hour, and that's the speed of the boat. Skip 28 for just a minute. I am going to come right back to it. Let me show you something on number 31, and then we'll go back and do as much of 28 as we can. On 31, anytime you give me a problem about a circle, a square, a rectangle, or triangle, guess what I do first? Draw it. I don't want to make a chart for it. I can draw a rectangular tennis court. Here's my very best imitation of a rectangular tennis court. And length is the long side, width is the short side. The second sentence says length is 6 feet longer than twice the width. Who do I know nothing about? If length is 6 feet longer than twice the width, or just the width. I don't know anything about the width. I know something about the length, but I don't know anything about the width. So, yeah, let's let the width be plain old x. And again, the width is the short side. Somebody has to be plain old x, and in this problem, it's the width. If the length is 6 longer than twice that, how could we label the length? 6 plus 2x or 2x plus 6. It doesn't matter how you write it. What's the other thing we're given? The area, and how do you find the area of a rectangle? Length times width. Length times width equals area, and we know that area to be 2,808 feet. This is different than every other equation we've set up. What's different about this problem? I would just be so happy if somebody got it. What? What? It's square. It has a square in it, which makes it what kind of equation? A quadratic equation. This is the first quadratic equation. Don't just set x equals 2,808 or 2x plus 6 equals that. What do you have to do with a quadratic equation? First, you get it in standard form. And then you solve it by factoring or quadratic formula. You could at least factor out a 2, and you might have to use the quadratic formula after that. I'm just going to put factor or QF and leave that one alone. That's or, not of. All right. We did pretty well to get all but one of the examples done. Here's the totally up to you, totally optional part. I have an hour and a half of office hours now. If anyone would like me to stay 5 more minutes and help them set up this one, you're welcome to stay and I'll stay with you. If you have a class you need to zip to, you're welcome to go. But if you want to see number 28, then I can stay and do it with you. I'll have this video on iTunes a little bit later this afternoon if you need to look at this one. Bye. All right. 2 cars enter the Florida Turnpike at Commercial Boulevard at 8 a.m., each headed for Wildwood. They're getting on the turnpike at the same place, and they're getting off at the same place. That's what I got from the first sentence. Is that what you got? So here's my very best car headed to Wildwood. Here's the other car headed to Wildwood. It appears they're going the same speed, but perhaps that's not true. I haven't read the next sentence. 2 cars enter the turnpike at Commercial Boulevard, and they're getting off at Wildwood. One car's average speed is 10 miles an hour more than the others. The faster car gets to Wildwood at 11, which is a half hour before the other car. What was the average speed of each car, and how far did each travel? I'm not even thinking about X's right now. I'm thinking, what are the 2 components in this problem? I'm looking for here and here. Yeah, car A, car B, fast car, slow car, whatever you want to call it. I'm going to call it fast and slow, so I don't, if I say car A, then I have to remember A is the fast one and B is the slow one. I'm just going to say fast car and slower car. And just about any distance problem in the whole wide world is going to have what across the top of that chart? Yep. Can the 8 o'clock go anywhere on that chart? It's not a rate. It's a time. It's not a length of time. It's just a moment in time. It's not a distance. So let's just leave it for a second. One car's average speed is 10 miles an hour faster than the other. Who do I know nothing about? The slow car, rate, time, or distance. I don't know anything. Let's see. The average speed is 10 more than the other. I don't know anything about the other's rate. So if the slow car's rate is X, what's the fast car's rate? X plus 10, not X times 10. Does that make sense? Okay. The fast car arrives at Wildwood at 11. So it took him 3 hours. You might have to subtract to get what goes in the chart. That was the fast car in 3 hours. And that was a half hour less than the other car. So yeah. Well, the fast got there half hour less than the slower car. So the slower car, it took 3.5 hours. What's the total distance traveled by the fast car? 3 times X plus 10. Total distance traveled by the slower car? 3.5X. And give me a sentence that makes sense here. Not with no X's and no numbers. Yeah. And you don't have to write the sentences down once you can do word problems. But if you can't do word problems, writing that sentence down is going to be the key to understanding and becoming able to do word problems. So fast car's distance. Wait. Okay, what you said was true. You said fast car's distance plus slow car's distance is total distance. That is true, but not helpful because we don't know total distance. What do we know? We know the two distances are equal because they got on the turnpike at the same place and they're getting off at the same place. So we don't need part plus part equals total. We need the two cars' distances are the same. Well, that won't always be true. You know, it's not always going to be true that the two cars went the same distance, but in this case, it's true. Don't come back and say X equals 60. What is that 60? It's the speed of the slower car because that's what we let X be. The slower car rate is 60 miles an hour. It didn't just ask us for the slow car's rate. It said, what's the rate of each car? So the faster or the fast car's rate is what? 10 more than that is 70 miles an hour. And then we're asked, how far did each travel? Well, we know that they traveled the same distance, but how do we find that distance?
We divide.
If you go 60 miles an hour for 3 hours, well, The fast car is going 70 miles an hour for 3 hours.
Yeah.
Would you divide to find out how far you went? 70 miles an hour for 3 hours is 210 miles. And by the way, that should be the same thing you get if you say 60 miles an hour for 3.5 hours. It should also come out to be 210 miles. All right. Thanks for hanging around for an extra 9 minutes. I hope that helps you with your homework. It's assignment 8.
You didn't expect it.